All right, so the topic that we're going to be looking at here today are called conditional statements. And what we're going to be dealing with here today is something kind of strange. It's not going to seem much like we're doing math per se, but it's really going to pay off as we progress further along down the path of geometry. It's gonna pay off big time once we start getting into what we call proofs. So the topic is conditional statements, and our essential question, the thing that we're going to try to answer by the end of this lesson, is how do I create a conditional statement using the hypothesis and conclusion? So what is a conditional statement? Let's start there. This first part says conditional statements. They are logical statements that can be written in if then form. They're going to be written in this form called if-then form, and a conditional statement can both be true or false. So, what is this if-then form? Let's look at example 1 here. It says the statement today is Monday and tomorrow is Tuesday can be written as a conditional statement by changing it to if today is Monday, then tomorrow is Tuesday. So see what we did there? We added in this if part, and we added in this then part. So that's switching it into if-then form. And then it asks, is this statement true or false? Because like we said, these statements can be true, they can be false. Well, if today's Monday, then doesn't tomorrow have to be Tuesday? There's no way that today could be Monday and tomorrow couldn't be Tuesday, right? Tuesday always follows Monday. So I would say that statement is true. Example 2. Rewrite the following statement as a conditional statement by changing it into if-then form. And this statement says complementary angles have a sum of 90 degrees. Now, if we're going to change this thing into if-then form, we know we need an if and we need a then. So what should we say? Let's say something about if they're complementary, then they have a sum of 90, right? So how do we want to phrase that? Let's say something like this. If two angles are complementary, then they have a sum of 90. So we took the complementary part, we made that our if, and then the sum of 90 we added after the then, right? We added the if, we added the then. Now, those parts that I just highlighted there, right? The part that followed the word if, the part that followed the word then, those have names as well. They're called the hypothesis and conclusion. This says a conditional statement is written as if P, then Q. So P is the hypothesis. P is the part that follows the word if, and Q is a conclusion. That's the part that follows the word then. So hypothesis follows the if, conclusion follows the then. Okay? So let's look at example 3 here. It says determine the hypothesis and conclusion of the following conditional statement. If two angles are vertical, then they are congruent. So like we just said, the hypothesis follows the word if. So my hypothesis would be two angles are vertical. And my conclusion follows the word then. So that's going to be they are congruent. Now, important clarification here. Notice that I'm not putting the word if in the hypothesis. If is not part of the hypothesis. The hypothesis follows if. Then is not part of the conclusion. The conclusion follows the word then. All right, so make sure you don't fall for a trick like that. Counterexample. Next thing here, it says a counterexample. A counterexample is an example that proves a conditional statement is false. It satisfies the hypothesis, but not the conclusion. So example 4 here says, determine if the statements are true or false. If false, provide a counterexample. Hint, they're going to be false. This first statement says, if a fruit is red, then it is an apple. That is certainly false, right? That statement is false because I can think of a few fruits that are red but are not apples, right? We want to make sure that if we're coming up with a counterexample, we want to come up with an example where this part is true, but this part is false, right? We want a true hypothesis, a false conclusion in order to provide a counterexample. So what is a fruit that is red but is not an apple? How about a cherry? Right, it could be a strawberry. Could be plenty of fruits there that are red that are not apples. Lots of berries, right? Raspberry, who knows? Next one says, if a number is prime, then it is even. Now, that's certainly false as well, right? If we can just come up with a number that is a prime number but is not even, then we win, right? We want that to be true. We want that to be false. How about 3? Right? In fact, there's only one number that is prime and is even, and that would be 2. So, plenty of counterexamples there. We could do 5, we could do 7, 11, 13, who knows? There's literally an infinite amount of prime numbers that are not even. Okay, so far so good. We know how to write a conditional statement, right? We throw in the word if, we throw in the word then. We know what follows if, we know what follows then. We know counterexamples. Let's go to the inside. So next up, we have a bunch of conditional statements that are related to the original conditional statement, but we can do some things to mess with them a little bit. So we have these related conditional statements that are called converse, inverse, and contrapositive. And let's just read that first part there first for the converse. It says, a converse of a conditional statement is formed by switching the hypothesis and conclusion. Okay, so let's look down here and let's try that out. So example 5 says, use the following conditional statement to write all 3 related conditionals. And then they give us the conditional statement. They say, if 2 angles are a linear pair, then they are supplementary. So for the converse, remember what we just set up above. For the converse, we have to switch the hypothesis and conclusion. So if I switch those around, then what I would form would be something like this. It would be if, and this is going to be a little bit weird, but I'm going to leave the 2 angles part up at the front just for phrasing. But I'm going to say if 2 angles are supplementary, then they are a linear pair. So see what I did there? I put the supplementary part in the front and the linear pair part in the back. So I switched them. So that's how you form the converse. You switch them around. Now, this is kind of odd, but is that statement true or false? Now, the original statement was definitely true, right? If 2 angles are a linear pair, then they're supplementary, because a linear pair has to be adjacent and supplementary. That's the definition of a linear pair, adjacent supplementary angles. But this statement is false, because I can definitely think up a scenario where these 2 angles are supplementary, but they are not a linear pair. Like, imagine this. That angle right there is 100 degrees. This angle over here is 80 degrees. Those 2 angles are supplementary. They add up to 180, but they're not a linear pair because they're not touching anymore, right? They don't form a straight line. So that would be a counterexample. Counterexamples don't always have to be words. You can draw pictures as well to provide a counterexample. Okay, so that's the converse, though. The converse is where we flip them around. Now, next up is the inverse. Our definition here says an inverse of a conditional statement is formed by negating the hypothesis and conclusion. Negating the hypothesis and conclusion. Now, to negate something means to make it opposite, to make it negative, right? To change it into the opposite version. So that seems kind of weird, but you're going to see how easy this is. To make both the hypothesis and conclusion opposites, oftentimes all we have to do is just throw in the word not. So I'm going to say if two angles are not a linear pair, then they are not supplementary. So negating something is pretty easy here. Notice that what I did here is I left it the same, right? I didn't switch it like I did on the last one. I still have the linear pair part up front, and I still have the supplementary part in the back, but now I added the word not in there, right? That's how you negate something. And let's think about that. If those are true or false, if two angles are not a linear pair, then they are not supplementary. And I'm going to say that's false as well for the same reason that we had before. This counterexample with the 100-degree angle and the 80-degree angle that are not adjacent, those are not a linear pair, right? The first part is true, but they are supplementary. So the conclusion is false. So remember, that's how you come up with the counterexample. Make sure that the hypothesis is true, the conclusion is false. I came up with an example that is not a linear pair, but is supplementary. So that's a counterexample right there. So the contrapositive, this is the last one. A contrapositive of a conditional statement is formed by switching and negating the hypothesis and conclusion. We're doing both of the things that we just talked about. Okay, we're switching and negating. So for that one, let's do if two angles are not supplementary. Remember, we're putting the supplementary part up front. Then they are not a linear pair. So this is kind of the combination of both of the ones that we just saw. So notice that we have the two angles being supplementary up front, and we have the linear pair in the back, so we did switch it from the original way. But now we've thrown in the word not. And let's see if that's true or false. If two angles are not supplementary, that means that they don't add up to be 180, then they are not a linear pair. That's true. There's no way that two angles can not be supplementary, but also be a linear pair. So there's no way to make that first part true and that last part false. So what we ended up with here is a scenario where the original statement was true, right? We agreed with that one. If two angles are a linear pair, then they're supplementary. That has to be true. So the original statement was true. The contrapositive was true. But the converse and the inverse were both false. And that's a pretty good example of how these statements work, the truth values of them. This says that the original statement and the contrapositive will always have the same truth values. So they'll either both be true or both be false. And then likewise, the converse and the inverse will always have the same truth values. So the converse and the inverse will also always both be true or both be false. That those ones are always connected. Okay, so let's go to our last little bit here. We got example 6. Use the following conditional statement to write all three related conditionals. So we're doing the same thing here. So let's check this out. If you live in Los Angeles, then you live in California. So if we're going to flip that around for the converse here, we're going to say, if you live in California, then you live in Los Angeles. And notice here, of course, California, oops, wrong color. California is now up front. Los Angeles is in the back. Is that true or false? That's definitely false. You could live in San Diego, right? If you live in California, you don't have to live in Los Angeles. For my inverse, if I'm negating this one, I would say if you do not live in Los Angeles, then you do not live in California. And is that true or false? That is false, because if you don't live in Los Angeles, maybe you live in San Diego, and that would be in California, right? So once again, this is the same way that we saw it before. The same counterexample can be used for both the converse and the inverse if they're both false. But more importantly here, notice that we didn't flip anything, right? For inverse, all you do is you put the word not in there. You just negate them. Then our contrapositive, remember this is going to be where we switch and negate. So if you do not live in California, so I'm putting California up front, but I'm putting the not in there, then you do not live in Los Angeles. And how did we do there? We put the original conclusion up front, we put the original hypothesis in the back, and we threw the word not in there. So that's a good contrapositive. And is that true or false? That is true. If you don't live in California, that means you're not living in Los Angeles. So no counterexample needed here. Remember, we only do counterexamples when we're trying to show why something is false. Okay, so last thing here, the biconditional statement. What is this thing? This is our last kind of conditional statement. It says a biconditional statement can be written if both the original conditional statement and the converse are true. The biconditional statement is written as hypothesis, if and only if, conclusion. So we'll talk more about that here in a second. But in order to write this thing, we need to make sure that the original statement and the converse are both true. So let's look at example 7 here. It says use the following conditional statement to answer the following questions. If two angles are supplementary, then they sum to 180. That's certainly true, right? That's literally the definition of supplementary angles. So let's check the converse here. Remember, the converse is where we switch these things. So we need to put this in the back. We need to put this up front. So I'll say if two angles sum to 180 degrees, then they're supplementary. So notice summing to 180 is now up front, supplementary is in the back. And I did this earlier as well. I left the two angles part with the hypothesis just to make it sound good. Like if I just completely switched things around and I said if they sum to 180 degrees, then two angles are supplementary, I mean, it just doesn't sound right, right? You can make some modifications for the syntax of the sentence. That's fine. Now, converse-wise, being true or false, if two angles sum to 180, then they're supplementary. That's definitely true, right? That's literally what it means to be supplementary. So we have a case here where the original statement was true and the converse was true. So if both are true, then we can write our biconditional statement. And what we said in that box up above was to write it, we do hypothesis, if and only if, conclusion. Hypothesis, if and only if, conclusion. So what was my original hypothesis? My original hypothesis was two angles are supplementary And then I'm going to throw in that magic phrase, if and only if. Then I'm going to put my conclusion. They sum to 180. So altogether, two angles are supplementary if and only if they sum to 180 degrees. That's how you write a biconditional statement. A biconditional statement just implies that it works both ways. The angles are supplementary if they sum to 180, and they sum to 180 if they're supplementary. So it can work either way, which is why it's called biconditional, right? Bi means two. It's a double conditional statement. It works either way. That's what the biconditional statement means. Now, once again, we can only write that if it works both ways. So we have to check, is it true going forwards, and is it true if we flip it around for the converse? Okay, so your turn to check out those practice problems on your little half sheet there. What you've got here is you're going to be writing the converse, inverse, and contrapositive for one example. Then you are going to try to check to see if you can write a biconditional statement for the second one. So pause the video here, try those out, and then come back and see how you did. Okay, so hopefully you tried these out. I'm going to speed through these things so you can check how you did. For the converse on this one, we would say that if two angles share a vertex, then they are adjacent. And I'm actually going to say that that is false, because two angles can share a vertex and not be adjacent. Like, for instance, what about our two angles here? Right, our vertical angles. Vertical angles share a vertex, but they are not adjacent because they don't share a side. So inverse, then, we would say if two angles are not adjacent, then they do not share a vertex. And once again, remember the converse and the inverse are always going to both be the same. In this case, they are both false, and I can do the same counterexample here. My vertical angles here are not adjacent, but they do share a vertex, so that's not going to be true. Now, contrapositive, remember we're going to switch and negate, so this is going to be if two angles do not share a vertex, then they are not adjacent. Oops, sorry. And that one is going to be true. If they don't share a vertex, it's impossible for them to be adjacent. So that last one's true. So this is a case where the original statement was true, the contrapositive was true, but the converse and inverse were both false. Then example 2 here, our original statement, if a number is evenly divisible by 2, then it is even. That is certainly true. All even numbers are divisible by 2. Our converse would then be if a number is even, then it is evenly divisible by 2. And that's true as well. So we flipped it around. That's true. So that means that the biconditional statement would be a number is evenly divisible by 2 if and only if it is even. And that wraps it up there. So just remember, of course, for the biconditional statement, the number one thing you got to remember to do is put in that if and only if. Okay, hopefully that went well for you guys.